have now to compute for the series and strings. The series and string configuration of our battery bank. So to compute for the number of strings, we shall divide the required battery capacity, 245.69, and divide this by the battery capacity of the battery capacity rating of our battery itself. So that's 245.69 ampere hours divided by 250 ampere hours. So number of strings will be 1. To compute for the number of series, we need to divide the system voltage by the voltage rating of our battery. So that's 48 volts divided by 12 volts, and we have 4. So that means we need 4 of these battery right here connected in series. So that's it, 1 string and 4 pieces batteries connected in series. Okay, so now that we have all the data that we need, let us build our hybrid system. The hybrid system is composed of 4 major parts: the solar power array, the hybrid inverter, the battery bank, and the ATS, or the automatic transfer switch. The solar panels convert solar energy into electrical energy, and this electrical energy will then be used to charge the battery bank through the hybrid inverter. The hybrid inverter has a built-in charge controller that prevents the battery bank from overcharging. This hybrid inverter also converts DC voltage from the solar panels or the battery bank into AC voltage that can be used by the regular household appliances right here. The hybrid setup is connected to the power grid so that during the day it can function like an on-grid system while also charging the batteries. And during the night or during blackouts, the batteries will be utilized to power up the loads, just like the off-grid system. So, but when the stored energy in the batteries is depleted, the ATS automatically switches to the reserve or backup power source, and that will be the grid. Okay, in step 1 we have computed the daily power consumption by dividing the monthly electric consumption stated in the electricity bill by 30 days. In this example, the daily consumption is 5.67 kilowatt hours per day. In step 4, we have also computed the required battery bank load, which is 5 kilowatts. That is right here. In step 2, we have determined that for a daily consumption of 5.67 kilowatt hours, we need 4 pieces of this 380 watts solar panel, rated at 380 watts. In step number 3, we calculated that the inverter should have a rating equal to or higher than the power output of our solar array, which is 1.52 watts. In this example, we chose an inverter with a power rating of 3 kilowatts, which is higher than this. In step number 4, we have chosen which appliances are to be operational during the night or during blackouts. We have computed that the total load consumption would be around 5 kilowatts right here. So in order for our battery bank to supply power to this amount of load, we need around 4 pieces of 12-volt battery rated at 250 ampere hour each. And the next step is to compute for the circuit breakers. Okay, so DC circuit breaker number 1, this one. This is at the output of the solar PV panel. So to compute this, we need to multiply the short circuit current of our solar panel, which is 9.94 amps, and multiply that by the number of strings. In this case, we only have one string of solar panels, and multiply that by 1.25 as the buffer. So the current flowing through here is 12.42 amperes. In this example, we'll choose 14 ampere trip 2-pole DC circuit breaker. DC circuit breaker number 2 is at the output of the is at the input of our inverter, or at the output of our battery bank. So to compute this, to compute the rating of our DC circuit breaker number 2, we need to divide the maximum power of our inverter, that's 3000 watts, divided by the system voltage of our battery, which is 48 volts. So that's 3000 watts divided by 48 volts. We have 62.5 amperes. That's the amount of current flowing through here. So in this example, we will choose a DC circuit breaker with a rating of 70 amperes. So that's 70 ampere trip 2-pole DC circuit breaker. For the AC circuit breaker, at the output of the inverter, just before going to the load, we can compute this rating by dividing the maximum power of the of the hybrid inverter, which is 3000 watts, by our grid voltage, which is 220 volts. Again, this is an error. This should be AC, current AC. So that's 13.64 amperes. That's the amount of current flowing through here. So in this example, we will choose an AC circuit breaker with a rating of 14 amperes. So that's 14 ampere trip 2-pole AC circuit breaker. So the other accessories are the DC and AC isolator. These two functions as a switch that you can manually operate to turn on and off or isolate certain parts of the system. So in this case, the DC isolator can isolate the solar panels from the rest of the system, and the AC isolator can isolate the solar power system from the grid, which is the power grid, which is your utility. The AC, SPD, and DC SPD are your surge protection devices. So they protect your system from current surges by directing the surge current flow to the ground instead of going to your equipment, which can harm your appliances. So I think that's all. Yeah, so that wraps up our 5-part lecture series, and I hope you have gained some knowledge on solar power systems. I encourage you to read more and research more if you want to build your own solar power system. And yeah, I hope you had a great time learning. Have a good day ahead, and please don't forget to like and subscribe. And yeah, see you if I make any lecture series that would be something similar, or um, maybe with regards to telecommunication systems. I will let you know. So I'll keep you posted. So have a good day ahead, and goodbye.